DK, DK asked me to welcome our three guests. DK and myself, we know them really, really well because we've been, interacting with them for almost more than 2 years, right, Laurette? I
Yeah,
mean, yeah.
yeah, yeah.
Uh, Laurette is an amazing person. Okay, she resides in Montreal, but her footprint spans the entire world and that globe. Okay, and she's a McGill. She's a emerita professor. She's retired, but it doesn't feel that way. She's retired apparently, emerita professor at McGill and founding chair of this particular program MCCHE, and she's going to talk more about it, right? So, and her work is interesting. It bridges behavioral economics, consumer psychology, and and also health, right? The idea behind all, behind the convergence or confluence of these three topics is to drive large scale societal impact. So apparently, she started working with, with her advisor at Cornell, right, who is a Nobel laureate, right? So
Hmm.
some of these topics, and she's been pursuing them forever. Yeah. So she has very interesting interdisciplinary training. I just alluded to that. Nutrition, finance, all the way to behavior science, right? And pretty much, you will see that today, we have three. This talk is three parts, right? In the first part of the talk, she's going to discuss her, translational approach, and this is something she's been forging throughout her long life. Yeah. So just that's Laurette for us. So let me move on to the second speaker. Okay, Giancarlo. I met him almost 1.5 years ago. Lots of energy. Yeah. So he is a professor at full professor at University of Twente in. Did I say that right? The name Twente,
Yeah,
not
yeah, yeah. Sure.
not Twente.
20, yes.
Yeah, in Netherlands, and he's very well known. He's a global leader in formal ontology. Yeah, and conceptual modeling. So he's especially known for his work on unified foundational ontology and onto UML, right? So this is something he's well known for. His work integrates computer science with philosophy and logic, like all Europeans do. We don't do that in US, but Europeans tend to do that. Philosophy and logic to advance complex systems, as they are represented and engineered. I always had great conversations with Giancarlo. Hopefully we'll hear more today.
I
And
feel the same.
I'm
Yes.
sorry. Go ahead.
I feel the same.
Thank
That
you.
we always have great conversations. Yes.
Thank you. Thank you. So, Eric, last but not the least, is Eric. Eric is a force of nature. Okay, that's the best way to describe Eric. He's an amazing guy. Also, um, he's an American. He's an American who lost his way in Netherlands. He's from Michigan too. Okay, not far from us. Yeah. So but he still hangs out with us Buckeyes. Okay, and everybody else in Icicle. So Eric Schultes is the lead FAIR implementation engineer or scientist at the Go FAIR Foundation. Yeah, he's also the co-author of the FAIR guiding principles. Everybody knows about FAIR, right? Yeah, the NIH guidelines on how to share data and so on. And through his efforts, we are as he's this foundation, Go FAIR Foundation, is helping shape global standards for interoperable and trustworthy data systems. And a lot of his effort right now, it's not just on the data, but also AI and models. And that's something we've been discussing offline, and hopefully we want to push that further given some opportunities that are coming up on the horizon. So he has background in evolutionary biology, yeah, and data intensive science. Now, of course, he works, in with the foundation, Go Fair Foundation, and his interest is in AI and biomedical domains. He does a lot of work in metabolomics too. So this is essentially, my introduction to three wonderful people that I know quite well and I enjoy hanging out with. So take it away, guys. It's all yours. Love to hear what you would like to tell us. Yeah.
Thank you very much, Raghu. It's our pleasure to be here and facing the challenge to present what we want to present within 1 hour. So I will start very briefly by emphasizing, before I talk about what we mean by this precision convergence, if you read my long title, Precision Convergence Along the Computing Continuum for Real-World Impact at Scale. A lot of what we will be talking about, which has been 30 years of work to see, can we combine science and innovation for tweaking our model of Western development and Western science in a way that we go further? And clearly, why is it possible now at this point in time? It is for a large part because of the development in computing science and data and so on. And that is why I have been co-chairing with my colleague Sergio from PSC, Pittsburgh Supercomputing Center, this series, which is now 4 years, where DK, Raghu, Song recently have been keynote there, with this idea of how can we really work with those, all of you who are at the cutting edge of the next generation, science and computer and computing, to see to what extent we can build with you. And those are DK slides. Eric and I were hosting, and Giancarlo, in fact, we were hosting from Leiden on February 4th, an hybrid workshop where DK was with us, and that's part of his slide. I won't, the idea is not at all to go through this, but just to position the context of what we will be talking about. And here, this is from Song last week, March 25, where Song was bringing the perspective of Geo AI, because what we will be talking about is, can we position the whole person in the whole of society worldwide in a manner that is spatially and temporally positioned. And we have been taking food as the domain, our entry point, let's say, to create all around the world this approach that we call convergence, precision convergence. And here, if I briefly go over what you can read on the screen, it's rely on building organic coalition to bridge underground and digital powered health, food, other system initiative, whatever you take as entry point, and then to transform with the human as well as the digital capacity, finding a way to make it a value proposition that government, company, enterprise, and investor can invest time, brain, and money for creating this a better future. So it's not only a concept, it's also a way of doing and a way of measuring all three facets at the same time, while continuously learning and evolving toward transformation. And those transformations, as we will see, individual, community, enterprise, and so on. And the ambition is to sustain a growing network, and I would say a never-ending growing network of real-world projects that are connected in some way for those system transformation at multiple scale, and each initiative taking a distinct entry point, as I was mentioning earlier. And here, just an illustration that we will be coming back after later is to see, can we start with the human biology, human brain, and seeing to what extent can we combine human and digital, current science, current innovation, to build resilience at all, performance first and resilience at all of those three levels, the individual, the organization, and the population. So the agenda here, I am in 10 15 minutes at the most. I will provide a brief overview of where we come from. And then Giancarlo will be talking about the system engineering requirement and how can we be thinking about this in moving from requirement to infrastructure and so on. And with Eric, we will talk about how embedding FAIR everywhere into the data and models and so on. So our journey started well, it started in early 2000, but more specifically here, in 2012, we had a series of articles in PNAS as a special feature on these paths of convergence between agriculture, health, and wealth to say if we are keeping what we have been doing since the first industrial revolution, can we continue and get and keep the good outcome that we have been having, but try to address the externality that are not externality anymore. When we talk about human health and climate change and so on, that is not externality. It is the core of what we do in each of the sector that needs to be transformed. And in doing that, in the same special feature, I was working at the time with colleagues from Brooklyn Institution. This convergence by design here, it's really bringing all the system science approach that we know, but also bringing this kind of nesting, keeping the person nested in system for this adaptive real-world transformation. Because too often, either we talk of population or we talk of individual, and it is individuals are nested into their community, into the sector where they work, into the government that of the country where they live, and so on. And how to start dealing or embracing some of that complexity in a way that is scientifically sound, replicable as much as possible, accounting for context and so on, but also very pragmatically in system science, we need to look at initial conditions of where the world is now and seeing how we move from this in different contexts. So in 2014, then we had another special feature in the Annal of the New York Academy of Science this time. And that was this paper here is that it's not just about science. If we have to have real world impact, the linear view of doing science and then you translate and you transfer, it does not suffice anymore. We need to address the research question that the world needs to be answered. And we also need to work with those who are in the world with this able to engage in those transformation, whether it is private sector or government. So we have here this conceptualization that is to say, it's not just the science we need to combine. It is in any activity, we need to look in a convergence manner, economics, equity, social, health, environment. And this is easier done than talked about than done. But why I always call myself a pragmatic, optimistic person, I think that now two of the key building blocks we have a deep understanding of human behavior and human society as we never had before in their heterogeneity, their diversity, and so on. But we also have big data, artificial intelligence, and so on. So data and complexity are at the core of what we are talking about. And here, This is both. That's why I talk about precision convergence science and innovation. So we started a long time ago. Here you see that was work at the time I was doing with David Buckridge, who is a Mark Musen trainee, where we started developing ontology and digital architecture for chronic disease prevention. We were taking Quebec as the proof of concept, going from the Quebec, we have a single payer data, so going from the data, administrative data, medical data, and so on, to create an ontology and a digital architecture that would follow that. And one of the key points there, as you all know, is that in chronic disease it's not just the disease and the biology, it is all the systems that are leading us to have or not to have the chronic disease. And here, what you get on the right here, it is progressively evolving those digital architecture and ontology to move us for getting the outcome, the convergence outcome in the middle, but progressively thinking in a very, very modular manner how to assemble the digital architecture. And assemble here is not central planning, it's really working from the bottom up at the same time as you build some infrastructure, some overarching capacity. So from this, and that's the link with song, you see here, this was a paper in 2017 where for Montreal, we develop, and I will briefly talk about what we call mosaic agent, working from census data to have geospatial representation of the status of the population, of the positioning, also when you spatialize of the various actors there. And then here, that was a paper where, not surprisingly, the sales of soft drink were and the price elasticity of soft drink was varying importantly as a function of the socioeconomic status. So here, and I think Fahaz is on the online, and Raghu, if you remember, who were presenting this at PERC 25 last July, we have come up with this concept of mosaic agents, which are essentially to try to simulate this whole person in a whole of society. We need to go beyond population average by census tract or whatever and get high-dimensional digital representation. So those mosaic agents are created by fusing census-anchored synthetic population with high-resolution, deeply phenotype data you may have, and then through this, create this privacy-preserving ecosystem that captures socio-demographic, spatial, and empirical. So here, that gives a brief overview of what in this context we have taken Montreal as the proof of concept, and we are having a very, very fine-grained characterization of what's happening in the various sector and the various institutions and so on. And from that, then looking at, and here, this is how this mosaic agent as an hybrid entity. So it's part census statistic, part behavioral profile, and this behavioral profile can be parameterized as a function of information coming from different sample or different population with some criteria for matching the the cohort back to the census. And here, this data fusion architecture, you can think of it with the base layer, which is the census anchored, with also the actual geospatial positioning of things and organization and so on, and the fusion layer for enriching with behavioral and health data, and then articulating this hybrid representation that then you can use for agent-based modeling within each of the level, or and that's really song where I would love to go moving forward. Is that the example I will be giving here? It's We were creating those mosaic agent analysis nested at the census tract level. Does the helpfulness of the local food environment predict how consumer allocate spending? Does financial capability here? So here, financial capability is another database collected by the Canadian Financial Security Agency. And does this moderation operate differently across consumer and neighborhood? And here I will go very briefly in terms of the type of data that were brought together in this exercise. You got retail data from loyalty card. You get computing from the geographic position of various retail outlets. You could compute the helpfulness of the environment. We had the actual behavior of how much people were spending, and then you get the financial capability, that index, and we were also able then to do different angle for clustering, looking at the cluster of individual as a function of their consumption behavior, and looking also at the characteristic of the environment behavior typology. And here I will briefly highlight this point, because what you see here, you look at those results here. This is for the cluster of the heavy beverage shopper, which are favorite target for behavioral change for NCD. And what you do see here is that if you just what you get on the left is the amount of unhealthy spending on soft drink and so on. And the other one is the relationship with the helpfulness of the environment. And what you do see here is that when you start dissecting the relative effects of helpfulness of the environment and the financial capacity of the person in the given neighborhood, what you do see here is that improving the food environment work in the good direction only if the individuals have the financial capacity to act upon this. If they don't, you get the opposite direction. So this is that type of very complex dynamics of all those scales and layers impacting at any point in time the actual behavior that people are performing in the real world. So here I can, this is an IBM consumer store choice that Duo, one of our doctoral students, has been developing from this type of architecture, just as another giving a sense of what we have been doing, but so much can be done if we were to build a body of cumulative knowledge and tools and so on in this direction. And here I bring back songs slides from last week or so. Your model, your feast model that you have been developing, I would love that we build with you to see to what extent the relationship or the rules that you are having can be applicable in Nigeria, in Montreal, wherever, but also how we can add complexity is being able to get really this nested modeling structure. And I have a whole other aspects that I will skip to the benefits of my colleagues here. This is the action side of what we do. This FCI, which is when we talk about the science and action, we talk about really working in the uh, uh, in different initiatives on the ground that are happening. And if you link with the house that I was presenting earlier, innovating at the convergence sweet spot is where human health, planetary health, and inclusive prosperity are getting together. And this is here another representation of the whole of society. I will skip most of the other slides that you get here, which can be shared after, to come up with what we call of all of those different experience, and it's not just us at McGill or whoever is in the Precision Convergence Network, it is really thinking of all those various initiatives that work or that work less, to what extent can we extract principle of precision convergence? Because in that complexity, clearly it cannot be just rule by rule by rule. There has to be principle that then everyone can apply in a given context. And here I'm just giving the example here of the principle number 6 from the preceding slide, moving from binary views to continua and diversity of causes and solution. And look at those different binary, the West vs the rest, the money making vis-a-vis the meaning making, the rural vs urban, informal, formal, and so on. So each of the principles can be dissected in as many of those sub kind of way of thinking, and then applying this in different contexts. And that is why on that I will I will use this to shift to my colleague Giancarlo, who is the one looking at if we are to create this kind of better new world, let's say, what will be the feature of the system engineering and digital that can support this? Giancarlo, I will stop sharing here.
Okay, thank you, Loet.
Giancarlo, Raghu here. We have about 29 minutes, so if you and Eric can somehow sing a duet and finish within 20
Yes,
minutes or
I
so,
will try
25
to
minutes,
be, I
if you
will
don't
try to
mind.
be,
Sorry for the rush, yeah? Yeah.
no, no problem. I will try to be very quick on what I have to say. Um, oh, you're looking at the wrong, I'm sharing the wrong
By the way,
screen.
Laurette, wonderful talk. Actually, I haven't seen all the elements. I've heard you speak about all this many times, but first time I'm seeing it put together, and especially, focusing towards food systems. Very nice. Thank you for presenting. Yeah.
You you can see my slides, right?
Yes, yes.
So let me try to go very quickly through this. So what we need, I mean, the type of um, system that Lohet's talking about, so the idea of having a kind of cyber social system, right, is necessary because it would be impossible without managing the complexity of this entire ecosystem would be impossible without digital technology. So what we would need from an engineering point of view is a kind of real world tracking and intervening adaptive social system, or in other words, a kind of trustworthy real world digital twin. By trustworthiness, so something here that would be worth of trust, by that we mean, so one of the definitions of trust is that something is worth of trust if it has both the intention and capacity to act in a way that is positive with respect to our goals. So to be trustworthy here is to be aligned with the proper goals, societal goals in this sense, but also capable of acting according to these goals as these goals and circumstances change. So evolvable as well. So from a technical point of view, I just show you the list of technical requirements. I will, in the interest of time, actually group this in three areas and three grand challenges. One is knowing what we want to achieve, right? And this is a kind of requirement. So requirements and compliance problem. So given the goals and cultural and legal norms of that particular set of stakeholders, what how to represent this, how to reify this and have this as objects in our system. The second problem is a data management problem. So convergence literally means to lean towards a common point. So we have things coming from all direction that they have to be integrated in a proper way. So it's a massive problem of data semantics and data interoperation. So it's knowing about the right circumstance. There's a typo here. And third is knowing how to intervene, right? So having something this which goes much beyond human intelligence that is able to take the right actions and intervene in the right ways and in ways that are compatible with these goals, values, and norms. So very quickly through the first problem, as I said, these requirements and compliance problems, we need to have a systematic process for building and continuously evolving in a participatory manner models about individual goals, cultural values, and ethical, legal, social norms. Talking about the last part, so how to come up with intelligent intervention. So we have to intervene in the real world by recommending actions, including behavioral change, to the relevant stakeholders, considering this holistic perspective of the entire system, right? So to maximize what the system is able to produce. But also in a way that is personalized to those individual stakeholders, considering again their goals, values, their backgrounds, and in a way that makes sense to those stakeholders. So in an explainable manner. For that, we need to have models about sophisticated formal models that would support reasoning about all this, about goals and goal satisfaction and relations between goals, about risk and risk propagation, about trust and legal relations, events, causality, and so on, so that these intelligent interventions would result from a combination of several different strategies, intelligent strategies. So a kind of hybrid, human plus machine, and neurosymbolic architecture, so different types of machine models. For example, combining machine learning models that will make predictions about future events and how they are taken into account in symbolic models of risk propagation. And again, we need that these models are truly explainable to the stakeholders via this process of interventions. One of the things that we believe would play a central role in all this, addressing both the representation challenge of having nuanced representations of all these different aspects, but also supporting this kind of sophisticated symbolic reasoning. And third, helping with the integration of data is to have not an ontology, but a network of ontologies. So we have a complex system of ontologies in multiple levels, starting with a very high level, dealing with the most general concepts of events and causality and dispositions and different types of dependence structures. From this very basic foundation, we can build models in domains like risk that will start forming networks of models dealing, for example, with what is risk and what is it, what we need to reason about when talking about risk, but also value, security and safety, trust, resilience, and so on, forming these networks. And this can be extended, this core network can be extended into a network of domain-specific models dealing, for example, with food security and safety. So we have here three levels: a level of domain agnostic models, completely domain independent models, and one of the things I've been busy with for the past 25 years is this one particular foundation ontology, in this sense, system of these domain independent theories connected in a provably consistent way. The unified foundation ontology with the upcoming ISO standard. Here we have what is this middle level, which a level of core ontologies, and then we would have domain-specific ontologies, which are these ontologies which are participatorily designed. And this would help to form to address the eye of FAIR, let's say, right? The interoperability problem of FAIR. So we need to have this data ontology enabled data platform to deal with real world data and metadata in this kind of distributed, flexible, scalable, resilient, and accurate manner while guaranteeing data privacy and security. So we would have all these different data sources coming from all different directions, including unstructured data sources that would be integrated via this network. And then we could talk to this network, query this network using this common language of the ontology without having to have any actual integration, no global schema. And the answers to these queries would have to respect policies and privacy norms, and also, as I said, these goals and values and social norms, right? So this idea of policy-aware ontology-based data access. The way we form these networks typically is by building solid alignments between incoming new ontologies in different domains and this core network. What we see in a domain like this in the real world is they need to have also flexible alignment. So we need most of the techniques we have developed over the years for ontology alignments. They strive for precision and for accuracy. I think in this scenario we need to have some sort of flexibility that would allow for sophisticated model alignment techniques that will be able to answer things in a good enough way given the goals at hand, right? So a kind of adaptable alignments that are good enough given the set of goals that we have at a particular moment in time. So alignments that would be satisfying goals as opposed to satisfying goals in a strong sense. The situation tends to be even worse because sometimes we also have models, ontology-like models, but models for domains for which a consensus hasn't been reached yet. So we need to deal with this problem of model formation in domains which are very unstable and in which consensus are still being formed. So think of the COVID pandemics in the beginning of the pandemics, or even think about AI nowadays, in which there's still a lot of noise, a lot of things we don't know. So, in addition to this solid, stable ontology, we will need to have ontology-like models which will tolerate different views and different levels of consensus. And then we need to have these different levels of alignment. So certainty moving in this particular way, going from light alignments with unstable models, light alignments with stable models, and rigid, solid, stable alignments, right? Again, we need alignment techniques that can deal not only with precision and exactness, but also with this kind of goal-based satisfying with rough, approximate, near sameness type of alignments. I will stop here and then hand it to Eric. We'll talk about a particular goal of semantic enriched objects in this FAIR platform.
Thank you, Gianluca. I believe there was a question. We can address it after Eric's talk, or if you want to address it now. It's a question from Michelle. Would you like to go first, Eric, and then answer all the questions?
Yeah, I would
Okay.
suggest we go
Yeah.
with
Yeah,
Eric and
okay.
then
Got
address
you.
the
Thank you.
question. Yeah.
Thank you.
Great. Then I'll go ahead and share my slides. I think you can see that now.
Yes,
Um,
you can put it in
yeah,
presentation.
so let's go here. Sometimes I'm noticing that my keynote will get hung up. So if you think I'm switching slides, but you don't see that, let me know. Give me a warning. So thank you, Giancarlo, and thank you, Laurette. What I see in this lineup of the three speakers is with Laurette, we have this very broad view of a data infrastructure that could accommodate these goals of science and innovation that somehow surpass the difficulties that we have at the moment. Giancarlo has given us, I think, a theoretical foundation or the beginnings of a theoretical foundation for what that infrastructure would look like. And what I would like to do is give you a view on an existing data infrastructure that I think in a very rudimentary way begins to address the issues that Giancarlo and Laurette have been discussing. So, we'll say this is from requirements to infrastructure, and I'm going to borrow heavily from Giancarlo's presentation. I'll say fair digital objects for real world tracking and intervening in adaptive cyber social system, which is Giancarlo's title. And I think if I try to summarize Laurette's higher level message, basically AI is essential, must be essential, I think, in the management of social technical systems. But this implies a very strong synergy between humans and machines. It implies data that flows, that follows FAIR principles, and AI systems that are empowered by that. And it's also achieving this will require some kind of infrastructures. Sorry about that. Okay. And, I think with ICICLE and the fair digital objects that I'll present right now, we begin to see already the beginnings of infrastructures that can begin to accommodate these issues, these requirements. I would summarize Giancarlo's message. Sorry, guys. Oh, yeah, okay. That's coming from somewhere else. So I will talk through the phone. So Giancarlo's message, and I'll read this. We need to manage real world data and metadata in a distributed, flexible, scalable, resilient, and accurate manner while guaranteeing data privacy and security. So what I will present now in some approaches that we've been implementing at Leiden University, I think we can already claim to address some of these issues, like I say, at least in a rudimentary way. So high level view on FAIR. So I'll summarize my 10 years of working at Go FAIR in two very simple slides. We've talked about FAIR data. That's data that is findable, accessible, interoperable, and reusable by machines. as well as humans. The definition in the original paper was that FAIR was meant to enhance the ability of machines to do FAINR. So we're talking about automating those processes. And then if I have to say it in 2 words, FAIR boils down to increasing the context and decreasing the ambiguity of data. That's essentially what we're trying to do. If you can achieve that, your data will be more computable in a deterministic sense. It'll be more trustworthy, and it'll be more equitable. And this is all together to try and make data and services more reusable by humans and computers. There's many ways to implement the FAIR principles. The last 10 years has seen many different approaches to this. I will talk about one approach called FAIR digital objects. And basically, an FDO is a globally unique, persistent, resolvable identifier that will resolve to a very small, minimal metadata record. That record will contain minimally 3 things. It contains a type of thing that we're talking about, the location or access protocols to get to that thing, and a little bit of type-specific metadata. And if we're talking about FAIR digital objects, we think of the thing as actually a digital object. And so there's a FAIR component to this. There's the object component to this. And what I'll show you today is a progression that we've been working on for about 4 years now. And I just returned from Vienna at the 3rd FAIR Digital Object Conference. It's an international meeting, and very exciting to see industry, the Austrian government, etc., getting involved. But here's getting a little bit more concrete. We might have different kinds of digital objects, sensor data sets, say, documents, or even entire databases. Each of these things should have identifiers, should have type specifications, links to get to them, and some metadata. And that very basic metadata will be quite generic in most cases, the same for each of these objects. Although you can always add or extend that generic metadata with type specific. And I just made this slide while listening to Laurette's talk. She was talking about mosaic agents. So for example, each of these agents could themselves be a FAIR digital object, and we could create records for those. I will tell you about an implementation of FDOs that we've been working with. These actually go back to Leiden itself. There's a long history to nanopublications. It came out of the groups that we are working with in Leiden. The nanopublication is basically a single assertion, a single semantic unit of information that is given provenance, and then that assertion and provenance is packaged in a container, a uniform container that itself has metadata, the publication info, and an overall identifier. And I just wanted to mention a few things. The nanopublication is based basically on RDF graphs and open HTTP protocols. So there's really not much special about a nanopublication. It's just a configuration of existing web protocols. But there is, as of today, I'll say, global nanopublication server network. It's a decentralized network that offers services on nanopublications. It helps you. There are services for helping you to publish nanopublications, to find them, to provide date and timestamps, authentication, to store nanopublications. In this way, the nanopublication universe is a mature ecosystem or a mature information infrastructure. An example of what a nanopublication could look like, your assertion might be a scientific claim. low levels of vitamin D are linked to hypertension. Someone might have said that on a particular day in a particular journal. It could be that a third person came by to repackage that information as a nanopublication and publish it with a persistent identifier. What we have done is we've used nanopublications and we've used the assertion to embed this type, location, and type-specific metadata, essentially the core elements of an FDO. And we can, with nanopublications then, point to various objects, digital objects, and give them identity. And the nanopublication server network provides already a lot of services to help us process that information. Very important, and I should say, we're doing this work in the Metabolomics and Analytics Center. This is a high throughput metabolomics laboratory. I'll show you a schema of that in a minute. We have a governance group that maintains our vocabularies, our ontologies, and our, I could say, liquid alignments that Giancarlo was talking about. So the governance group is absolutely essential to this technical picture. Here's a snapshot. If you want to work with nanopublications, or basically, one incarnation is they look like web forms. You fill in the blanks, push a button, and you create your FDO. And I wanted to point out that the control on vocabularies, the maintenance of our vocabularies, is itself something that we can do via nanopublication templates. So in a way, we have FDOs for creating our ontologies that can then power our FDOs that point to objects. So it's really this recursive FDO universe that allows us to build out some of the features that Laurette and Giancarlo were talking about. So here's a very limited starting point for what we do. Here's our laboratory. Typically, if you look on the top row, we have clinical trials. People bring us large numbers of human biosamples. We process those samples in mass spectrometry. We get data. We process that data and eventually get to something we can publish. Along that pipeline, we generate lots and lots of documentation. And that documentation is, on the one hand, really valuable scientifically, if anybody wants to really understand what we're doing. It's made even more valuable if AIs can view this information. But it's also a data management problem. How do we track all this information? And the idea is that we're creating nanopublication templates, FDOs, that point to these objects, making them fair digital objects. So we can build a knowledge graph in our lab for the process and the output of the laboratory. This is an example of a research object. So these are nanopublications that are pointing to various objects in a project we have called Project Stay Ahead. There's a schema that helps us with this. In GoFair, we've worked with funding agencies to create the FAIR funder framework. And this is a way that you can interconnect these FDOs in a way that makes it interesting and valuable for, on the one hand, government funders, funding agencies, and on the other hand, the scientists who are actually doing the work. And so you see in the yellow, we have project administration, kind of the management of the funding aspects. In the blue, we have the scientific. And where I've drawn a box around the nanopubs, those are the nanopub types that we're working with at the moment. And I'm going to submit, that this very simple structure of just identifying objects for what they are and making them machine actionable is already analogous to the domain-specific and domain-independent aspects of a data infrastructure that Giancarlo was talking about. I believe the nanopublication framework like this answers to this question of a systematic process for building and continuously evolving our models in a participatory way. Right? We have the MAC Fair Governance Group where everyone can contribute to this. And this is also an interaction between funders and scientists in creating these ethical, legal, social norms. And it helps us to manage this complexity at these multiple levels. Here's a list of queries that are now possible that are in general inconceivable. It's not even possible to imagine how you could ask these questions in a general way without some kind of information infrastructure like this. And I'll read these off, right? So they sound trivial, but they're very difficult to realize in practice. Find me all data sets created in the analytics center in a particular time frame. Data sets are created, they're stored in many different places. People come and go in the lab. We have no idea where all of our data sets are. Find me all the articles published by a particular person. That's in general a very difficult question again to know that with some certainty. Find me all the methods that we developed in the laboratory under the hypermarker project, particular project. Give me information on instrument logs related to data sets published in a certain time frame. Those instrument logs being critical for quality control. If there's something systemically wrong with the instruments, we could track that. Find me all the data management plans created in our laboratory. That would be wonderful if we could do that. Find me all the data management plans for projects funded by a funding organization. That would be absolutely mind-blowing if that could be done. Find me all the data management plans related to a particular topic like hypertension. Maybe I can reuse DMPs and not have to recreate them over and over. And I think this is speaking to these other points that Giancarlo made regarding the liquid alignments and having, in some cases, very exact and precise ontological descriptions, but being able to have these units in such a way that agentic agents can read them, understand them, and provide a kind of a liquid alignment on these. And it's also, like I say, the ability to create ontologies on the fly with FDOs is, I think, a breakthrough for most research scientists and users. And finally, I'll just say, coming back to Giancarlo's message again, I think this FDO approach, this nanopublication-based FDO approach, is certainly about data and metadata in the real world. It's a distributed ecosystem. It's highly flexible. We can work with funders, we can work with scientists, we can work with business, we can work with governments. It's scalable. These are just triple stores that we're building up. Resilient and accurate. So in the last 10 years, not one nanopublication has been lost from the network. I think there's several millions now on the network. The idea of data privacy and security is something to be developed. The nanopublication server network right now is radically open, but we can imagine, as far as security and privacy is a metadata aspect, we can build nanopublications for that as well. So we have prototypes for that, but we haven't developed it out yet. And with that, I'd like to say thank you and happy to have a discussion if there's time left.
Thank you to all three of you. I think this has been extremely illuminating. And although I heard all this before, it's still illuminating. Okay. And one of the things I would certainly do is to open the floor to everybody, but make sure that some of the questions from Michelle, Alfonso, and Song are first answered. So once we answer them, Nilima, is it okay if you go a little longer, like 10 minutes or so, 10 to 15 minutes?
I don't have any problem. I'm assuming Laurette, Giancarlo, and Eric
Okay.
are available. So
Yeah.
respect everyone's time here. So yes, absolutely. We can open up the floor for a question. As I mentioned, Michelle had a question.
Yeah.
Michelle, would you like
Let's
to?
start with these three, and depending on the time, we can, perhaps invite more questions. Yeah. Okay.
Okay. Michelle, you want to ask a question?
Yeah, sure. I can verbalize it. So I work with tribal communities quite a bit, and one of their concerns is that they don't see themselves as individuals; they see themselves as members of a community, very strongly that way. And many are separate nations from the United States, and so a lot of the work that I've seen is very individualistic. or talking about legal issues. I think there are also structural issues, especially in food systems work. And I'm worried about, modeling and data limitations that amplify the inequities that are already present rather than helping us, dig our way out of this situation. How do you address that?
Uh, Giancarlo, you want to go ahead, or I may give a quick reply. I completely understand what you're saying, Michelle, and I think that this individual, community, city, and so on, it is not kind of it's to get rid of this dissociation between the individual and the community that has been structuring Western development, and keeping this nesting as much as possible as a way to understand what human being by themselves, in their family, in their community, and so on, act at a given point in time. And when we talk about data, we need to think about more knowledge and practice. And I think there's a lot to learn from indigenous community. It won't be the same type of data that you collect in supermarket cash register, but it is important knowledge and practice that if we want to avoid that the traditional village kind of leapfrog to all of a sudden those big mega city. This kind of common ecosystem that I think we need to think from the beginning. It's not an either or. We do need the informal knowledge and the indigenous practice and so on. The idea is to see, can we develop differently in trying to alleviate the inequity that has been built into the Western way of development. So I don't know, Giancarlo, if you want to add to
Yeah,
this.
I also fully agree with Michelle's comments. I would just very quickly add two things. One is I think it's quite important now that for the first time people doing data modeling are really not, in a more global view aware that modeling choices embed ethical choices, and they do create reality and
Yeah,
perpetuate reality, right? I think one important contribution here of this style of modeling that I was proposing is that these models should be very explicit with respect to the commitments which they embed, including the ontological commitments. So, what are the worldviews embedded in those models,
yeah,
represented in those models? So, this is a sense of explainability that I think is quite important, right? So, in the sense to explain, is to kind of reveal this worldview behind the representation, but also models that are contestable, that are very clear in the kind of propositions they are making. And beyond the models, we need to have governance process in the construction of the models and in contesting what the propositions embedded in these models. I'll leave it at that.
Uh, I will need to leave because I need to be at an interview. I wanted to spend maybe 5 minutes or so. Nilima, if I hand it over to you, would you be okay? And I just wanted to apologize for my quick exit. Nice to see you again, Giancarlo, Eric and Laurette. Eric, I'll be reaching out to you again very soon. But I would like to be excused from this event today. Thank you very much. Yeah.
Take care,
Absolutely.
Raghu.
Yeah. Okay. Thank
See
you.
you later. Hey, folks,
Okay.
just a quick hello from Alfonso Morales over here. My team at the UW did the feast, and I was thrilled by the response to Michelle's, my colleague Michelle's question, Laura, you and Giancarlo. I believe very firmly in this notion of that here in my lab at the University of Wisconsin at Madison, we are the research assistants of community.
Mm-hmm.
Mm-hmm.
Community is the PI in our language of their lives.
Very nice.
And so I'm in keeping with y'all's presentation. There's so many things that I could either suggest or ask about, but let me just leave it with the idea that we would be happy to collaborate with you all further. And
Yeah.
we have a couple of software products. We have the Feast, which you called out. Thank you. And we have a mature software. It's in its 2.0 drop. It's Farm to Fax. And there's a Canadian
Oh.
version of it, Laurette.
Oh,
There's
really?
yeah,
Okay.
yeah. So I'll drop that in the chat, just FYI to
Okay.
you all. But anyways, farmtofax.org. Um, so, please feel free to reach out to me. I'll drop my email in there as well. Whoops. So I'll be quiet now if somebody else should go on. Thank you for your attention.
No, excellent.
Thank you.
That really was one of my objectives. So,
Okay, let me just say very quickly one thing. It's very nice to hear that. And in terms of collaboration, I'm participating in a project. I'm one of a co-PI of a big project in the Netherlands that has the same subtitle as ICICLE. It's about
democratizing.
the yeah, it's called Decide and the Democratizing. So the subtitle is Democratizing AI, Empowering Citizens Through Transparent Decision Making. So many of the things we are discussing here are strongly connected to the project. So it would be wonderful if you could find a way to collaborate there.
Absolutely, Giancarlo. I think we have our three, the digital agriculture, food systems, and also our animal ecology. And I was looking
Yeah.
at some of the applications in the nano publications, which align very closely to some of our projects. So happy to collaborate if you all want to, reach out to me, and we can get folks, get talking to you all for any of the collaborations that you would like to. So.
Great. Thank
Thank you
you.
so much. Any other questions, Alfonso? I think your question was addressed, right?
That's correct. Thank you very much.
Okay.
Other folks can go
Okay.
on. Thank you.
Okay. Uh, if there are no more questions, I would like to thank Laurette, Giancarlo, and Eric for taking the opportunity to speak with us. And if you can share your slides, and of course, this recording will be available on our YouTube channel as well. Thank you all, and have a nice day.
Thank
Yeah,
you
thank you
very
so
Thank
much.
much.
you
Very
for having
very
us.
Bye.
Thanks,
Bye.
everyone. Have a great
Bye.
day.
Bye.
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 Bye.